This time our task is to remove duplicate characters from string, and here is the description. Given a string s, remove all duplicate characters while preserving the order of their first occurrences. And so we have one input, string old s, or could be called anything, doesn't matter, just there is a single input, and we have to figure out whether inside that string there are duplicate, meaning one character occurs more than once, and preserve only the first occurrence. So the order matters. We have to remove the next occurrences. Maybe there is like a second occurrence, but maybe it is duplicated or repeated multiple times. It could be the case that, for example, we have character A at the beginning, then A at the end, or maybe A is repeated 100,000 or 100,000 times. And by the end, we have to return the resulting string, and constraints are as follows. 0, the length is between 0 and 10 to the 5, so it could be an empty string, and it was definitely fitting into memory with 10 to the 5. Then S may contain letters, digits, spaces, or special characters, which is also important. Of course, you cannot assume that those are just letters, but normally all of those other characters like digits, spaces, and so on are from the set of extended ASCII, which contains 256 characters, which is something that matters, especially for those kind of tasks, because already we can try to think about the solution. And if we have just 256 possible characters and we want to remove the duplicates, that means that our string, the resulting string, will be at most 256, which is very small when it comes to tasks like this. And we should try to achieve an efficient solution with O(n) time complexity and minimal extra space. And here are some examples. First example, input Google, and of course we have O duplicated. So the first O is preserved, the second is removed, and also G appears here and then here. So the second occurrence of G is removed, and we end up with this goalie or goal, however you pronounce it. And then in the second example, we have ABC, ABC, on the first ABC space, the second is removed. And then we have A in the third example repeated 4 times, and we just keep the first A. Then below we have some place left for us to fill in. And we will start with a brute force solution and then try to optimize it. And in the end, we'll have 4 solutions which will vary when it comes to the time complexity, but will all achieve the same goal. And below we have just some test helpers, so functions that the test cases themselves and functions that are used to run the tests. And here we have the test cases. We have the examples that we had before, like basic repeat, some all the same, A repeated many times, empty string, mixed repeats, all unique, and so on. And we will also have some random test cases. And then we run all our solutions. So let's start from the first. In the first approach, we will try to, or we will not try, but we will do it simply, create an additional string called result that will return by the end result. And instead of removing characters inside the input, we will simply be adding the ones that we should preserve, the ones that are not supposed to be removed or deleted, to the result. And that's the whole idea. So now we go through each character. Through each character seen in the input, and if it's already in the result, then we don't want to add it anymore. Here we want to only add it once to remove the duplicates. So we want to check whether result.find for that character C returns something that will tell us that it's not there. And if it's not there, then find on strings returns std string npos. Then if it's not there, we want to add it, and we do simply push back. And theoretically, because find is a linear operation and we go to each character input, this would be like n squared time complexity, but actually it's not. In practice, it's not because of this limitation that we already discussed that the maximum amount of possible characters here will be 256. So no matter how big the input string is, let's say it has 100,000 or maybe even million or 10 million characters, this doesn't matter because in the end they would have to be duplicated many times. And even if A appears, let's say 100,000 times, then in the end, in the result, we will only keep the single A that was the first in the input stream. Yeah, so this is theoretically a linear operation inside a loop, which gives n squared, but in practice, for this particular task, it's really bounded and it will not be n squared. Or it will never be slow, defined. And now let's check the second example, or let's implement it as well. We also do additional result, turn result, and instead of finding in a string, we can find or try to look for the character in a more efficient manner using std string unordered set of characters. Sorry, not std string unordered set. What I'm talking about? Std unordered set. I was thinking about two things at the same time, and let's call it C. Yeah, and usually the set is the way to go when it comes to search operations because it's so fast, especially if we care about uniqueness, like if you only care about unique elements, and that's what sets are all about. Yeah, so removing the duplicates and fast insertion, fast lookup, and so on. So if you want to search for something, it will be faster to do it in a set than in a string, especially this search is not really for an index, like we don't want to find the position where the string, when the character is located in the string. We just care whether it's there or not. So theoretically, set would be much faster for that, but in this practical example, like in practice for this particular example, this will always be fast as well because of this bounded possibilities or the possible characters only coming from extended ASCII. And so this is like just for the sake of practice, nothing that we would really care about in practice, but it's good to know that sets are faster than strings when it comes to those operations. And for char C in string, we can do the same. We can insert and check whether it's already there in the same line by doing saying insert C. And insert not only inserts, but also returns something. It returns a pair, where the first element of that pair that this insert returns is an iterator to that element that was inserted, and the second is a boolean whether it was already there or not. And so if it's already there, then insert won't do anything, but the second element of the pair, not seen by second, I'm mixing up stuff a lot today. Yes, so the second element of the pair will be true, is a boolean and will be true if it's already there. And otherwise we push back to the result, the character, if that condition is true. So now the third approach will use the same stuff as here. We can actually copy it. Put here. And here finally we'll try to remove something by really removing it instead of just creating a new space. But still we will allocate a new space for that removal operation, and we will simply copy the input string into a new string that we still call result. And of course we return the result by the end. And now we will remove using result.erase. Yeah, and for the erase, or inside the erase, we'll use std remove if, yeah, which accepts the range first of all. So from the result, from the start till the end, and now it needs to know what kind of things we want to remove. So we'll create a function, a lambda function, that will be used to decide whether a given character should be removed or not. And we will give it access to this set scene, and then its parameter that it accepts is char c. And now here we were checking whether we want to preserve given character, and here we are checking whether we want to remove given character. And then both operations were based on this scene unordered set, but here we will do an opposite operation to this one. So if scene count, see if it's there, then return true. Otherwise, opposite operation, otherwise insert. And see, insert C and return false. Now we can close remove if, and we can also close the range result dot end. That's it. Now the final approach in place should be the fastest one and the one that wastes the least amount of memory. But even in case of those approaches, in practice, if you try to like compare their speed, I would say maybe even we can do it at one point, but I would say just from the experience that I have and my intuition, they would be almost the same. So there wouldn't be much difference when it comes to practical speed. But still, it's good to know different approaches and how they scale. So here we will use again a set, but this time not unordered set, but bit set, which is even faster than unordered set. And finally, we'll take advantage of this information that at most we can have 256 different characters, because that's exactly the number of characters in extended ASCII. And we can call it scene again. Then we create an iterator. And iterator is just pointer to a single character or a single place. It will not grow. It's just, we will use it like, let's go to writer to update the string itself. Yeah, but because it's like just a single pointer and not, it doesn't grow, then we can still consider it as almost no addition to memory, and the space complexity will be O1. So we'll start, of course, from the beginning. And the whole idea is to use the writer to update the characters one by one at the beginning of the input string. And then we'll be left with some part of that input string which won't be updated, which will stay the same way it was before. And that part we want to get rid of, and we'll do it by the end. So s erase writer and plus end. And now for auto iterator, I will use this iterator to go character by character, and this to update the string itself. Starting from s begin, At the beginning, they are the same, and till it's not equal to s_end, plus plus update by one, move one to the right. Iteration. Because we used bit set and in the string we have chars, we need to map them, or we need to cast them to unsigned chars. And let's create a new variable for that. And bit set uses unsigned chars and string chars. Static cast unsigned char. And how do we get the character that we are currently interested in? By using star operator on the iterator and converting it to value. This, and now if scene doesn't have that character yet, to check whether it's there, we use test, and to add something to the bit test, we use set. If it's not yet there, then we want to set it. So scene set scene, and then we want to also put it to the writer quotes, yeah, current value of the iterator. So iterator will go through each character, but we will go here only when this condition holds, meaning we will just update writer for each unique character. But after we updated its value, we want to, or the value to which it's pointing to, we want to move the writer to the right by one. And then we'll end up having, as I said, at the beginning, right from the left, starting from the left of the string, all the unique characters, and then at some point, all the characters the way they were originally, and this erase will get rid of those that are not unique. That's it. Now we can test. $69, not string, but input. And that's it. Now we can test. Something failed. The simple solution failed. That's interesting. Opposite. Yeah, so if it's equal to n post, then that means that it's not there. Not equal. And that's it. All tests passed successfully.